question involves a building with two service entrances fed from a utility-owned pad-mounted transformer. Service number 1 is 1000 amps at 120/208 volts with a 1000 amp main circuit breaker. Service number 2 is 1200 amps at 120/208 volts with a 1200 amp main circuit breaker. Feeders for both services are buried beneath the slab and enter the building directly into the bottom of each service cabinet. The building owner wants to install a generator to run the entire facility during a utility outage. A proposed solution involves installing a 2000 amp 120/208 volt service entrance rated automatic transfer switch beside the utility transformer. This automatic transfer switch has a 2000 amp service entrance rated main breaker on the utility line side. It is proposed to tap the load side of the transfer switch to feed the two services. National Electrical Code Section 240.21 B5 seems to support this approach, but there are concerns about the need to install overcurrent protection or disconnecting means for each feeder at the automatic transfer switch. The existing main breakers at each service will protect their line-side conductors just as before, but the arrangement still raises concerns. An assessment of the proposed solution to install a 2000 amp automatic transfer switch next to the utility transformer and tap the load side to feed the two existing services raises several concerns, including the absence of disconnecting means. For National Electrical Code Section 230.71, each service disconnect must be within sight of and readily accessible from where the service enters the building. The proposed solution does not provide disconnecting means at the point where the feeders enter the building. Another concern is insufficient overcurrent protection. National Electrical Code Section 240.21 B5 allows a single automatic transfer switch to serve multiple service entrances if each feeder is protected by overcurrent protective devices rated at not more than the ampacity of the feeder. However, the existing main breakers at each service are sized for the circuit's maximum demand, which may exceed the ampacity of the feeder. Redundancy is another issue. If the automatic transfer switch fails or becomes inoperable, both services would be lost. This is a critical concern for a facility that relies heavily on its electrical systems. To address these concerns, an alternative solution is recommended. This alternative solution involves installing a transformer pad-mounted switchgear next to the utility transformer. Provide a dedicated incoming breaker for each service, for example, 1000 amps for service number 1 and 1200 amps for service number 2. Install a transfer switch or load shed system within the switchgear to enable backup power from the generator. The benefits of the alternative solution are firstly, dedicated disconnecting means. Each service is equipped with a disconnecting means located where the feeder enters the building, as required by National Electrical Code Section 230.71. Secondly, proper overcurrent protection. The incoming breakers are rated for the ampacity of each feeder, providing adequate protection for the conductors. Thirdly, increased reliability. The dedicated transfer switch or load shed system ensures that service can be restored to the critical loads in the event of a utility outage. There are some additional considerations. Firstly, conduit capacity. Ensure that the conduit feeding each service from the switchgear has sufficient capacity for the increased conductor sizes. Secondly, conduit routing. Route the conduits from the switchgear to the service cabinets in a manner that minimizes the risk of damage or disconnection. Also make sure there is proper labeling. Clearly label all equipment and circuits for easy identification and troubleshooting. In summary, while the initial proposal might seem to comply with National Electrical Code Section 240.21, B5, a closer examination reveals potential issues regarding disconnecting means, overcurrent protection, and overall system reliability. The alternative solution involving pad-mounted switchgear with dedicated breakers and transfer switches offers a more robust and code-compliant approach. This alternative ensures proper protection, isolation, and redundancy for critical electrical systems. When evaluating such installations, prioritize safety, code compliance, and long-term reliability to safeguard the facility and its operations. Always consult with a qualified electrical engineer and local authorities to ensure that the design meets all applicable requirements and regulations.